as Greg mentioned, my name's Gordon. I'm the creator of a newsletter all about APIs called Get, Put, Post. And the idea behind the newsletter is each edition features a different company where I talk to them about their API and killer app ideas that they want developers to build on their platform. And actually, a lot of those developers are probably in this room, and I've talked to a number of the companies here. Based off of that, you guys probably know that I'm pretty fired up about using APIs as sort of building blocks for new use cases. The best example I like to give is that if you're starting Uber or Lyft, first you need to think about, well, how can I send text messages to thousands or millions of users? And previously, that would be a nightmare. Now there's a great API you can use, and it's sort of like this building block that enables a much more complicated and advanced use case. And so that's why I was so excited to host this panel on APIs in the real world. It's all about using APIs to do something that wasn't possible before. And so we have three amazing panelists. First, I'll give you some quick intros, and then we'll dive into some questions and try to make it a relaxed discussion. I know we want to get to lunch in 20 minutes or so. So on the far end, we have Tess from Chain. It's a very cool blockchain company working on connecting real-world payments from big financial institutions like Visa to the blockchain. We have Max from Zinc, which is a YC-backed company that's all about making it really easy to buy anything online through an API. So they have an endpoint where you give them a product, say from Amazon or from Walmart, and your address, and the API goes out and buys it and can ship it right to your house. And then we have Sanketh from Smartcar, which is a new company. It's a little bit under wraps, but it's all about creating open REST APIs for connected cars. So let's start there. Sanketh, could you tell us a little bit more about your vision for Smartcar?
Yeah, so I think it'd be good to just start out and tell you a little bit about what we do exactly. So as Gordon said, we build REST APIs for connected cars to make it really easy for developers to communicate with vehicles. So what that really means is something that a lot of people don't realize is most new cars sold today are connected to the internet via 3G or 4G modems. And so we make it really simple for you to be able to send an HTTP GET request, for example, to find out where your car is located, or a GET request to see the fuel tank level, or a POST request to unlock the doors of a car, or set the climate to 72 degrees exactly.
Cool. I think one obvious question is that every car is a little bit different, right? I bet there are sort of diverse interfaces. If you're talking to a Tesla, it has all sorts of advanced functionality. You're talking to an 87, Chevy, it doesn't do very much. How do you, can you walk us through how that works in the car space and sort of how you deal with that?
Exactly, that's a very big problem that I think we work hard at solving for developers. So we make a standardized API that makes it, that I think a large part of it is documentation, honestly, to make it really simple for developers to understand what is possible and what is not possible with the vehicle they're interacting with, and making it also programmatically available. So if you hit up the endpoint to get the sunroof status on a car that doesn't have a sunroof, you need to be able to know that this car didn't have a sunroof, and you don't just get a 500 error saying, whoops, something went wrong. So a lot of it is baking in that kind of documentation programmatically into the API itself. And taking care of, like you said, older cars may be more limited than newer cars. So taking care of things like, the availability of endpoints and the speed that these endpoints may return at may be different depending on the type of car it is. So one thing that we have to work on there is doing intelligent type of caching systems where we can actually try to give somewhat of a consistent experience to the developer, regardless of whether the car takes 5 minutes to respond or half a millisecond to respond.
Cool. Max, you want to run with that? I know that if you're talking to Walmart, they might have an API through Walmart Labs. If you're talking to Amazon, they don't have that functionality. Like, how do you deal with that?
Yeah, we kind of address largely the same issue, where part of our job is to build a universal API to talk to any retailer in exactly the same way. A lot of retailers have their own proprietary APIs for, they don't really have any APIs for ordering, which is part of the reason we built it, but we also built product details, product prices, calls on top of them, because there's such a variety of kind of interfaces with all of them. And so in the same way, we standardized the way that you interact with them generally by making smart generalizations. Every every shipping kind of parameter can be boiled down to speed and price. And so by just generalizing to those two parameters, we can translate that to what that means on the different retailers, and take a lot of the burden away from the developers, so that with our API, if you want to check a product on Amazon versus a product on Walmart, all you do is switch the retailer to Amazon, from Amazon to Walmart, and switch the product ID from Amazon's to Walmart's, and everything else stays the same. And so you can make these really sophisticated applications that kind of use every product on the internet as your fulfillment center.
Cool. Tess, anything to add there?
Yeah, I mean, I think really the common thread between what the two of you have just described and some of the work that I do is really about abstracting away like the nastiest parts and most unpredictable parts of systems, and sort of providing an interface for developers that is just a little more tractable. I mean, in the case of a blockchain at its most basic is a list of transactions. It's a ledger. And so if you want, like, again, if you're just looking at that model, if you wanted to do something like get the balance that someone has, you'd have to go through and like tabulate every transaction, if that's just your model, right? So that's not really a great developer or end user experience, obviously. So I think really like the common thread here is making smart abstractions for usability.
Yeah, could you take that a bit further and tell us more about what you're working on at Chain and sort of what do you want people to build on top of those abstractions?
Yeah, totally. So at Chain we have a platform for building multi-asset permissioned blockchains, which is kind of like a mouthful. But in short, that's kind of like a parallel universe to Bitcoin. So we have another system that's very similar in terms of the cryptography and the distributed design, but ultimately is a separate system. And one of the major differences is that there's no native asset on it. So like the Bitcoin network obviously has Bitcoin. If you're familiar with some other blockchain systems like Ethereum, those have, or Litecoin, those have tokens on them. And ours is multi-asset. Which is really a decision we made for enterprises. So the idea with something like Chain is that an institution like Visa or like NASDAQ, which are two of the companies we've partnered with, can build their own networks that gain a lot of the technical advantages of the Bitcoin network without having to buy into the Bitcoin network itself. So they're really using it as a piece of infrastructure.
Got it. Thinking more broadly, what do you think some of the changes that are going to come over the next few years that are going to get Bitcoin and blockchain in more and more people's hands?
Yeah, I mean, I think the biggest challenge, and this certainly, we've heard a bit about, I mean, we keep touching on usability, but also documentation and things like that. But I think the most important change in order to further adoption is not going to be technical. It's going to be cultural. It's going to be around how much people understand these systems. I mean, up until a few years ago, it was a pretty niche, geeky thing. It's slowly becoming more mainstream. And one of the things that we have to fight is sort of misconceptions about what a blockchain is or what it's good for. And there's this hype, which is like a blessing and a curse because people get really excited about things that sometimes don't actually make sense. And so I think that actually the biggest, and again, this goes back to some of the ideas that people have been talking about around sort of sharing knowledge. I think those are actually the biggest challenges right now in terms of more mainstream adoption. Cool.
All right, let's come back to Max. One thing that's interesting about your API is it's sort of it's a wrapper on top of other APIs. Like we heard from Calvin at Segment earlier, it's sort of a similar integration problem. How do you deal when one of your downstream APIs goes down? Do you have infrastructure in place to handle that? Do you return a special error code? How do you handle that?
Yeah, that's a good question. One of the kind of problems that I see you having as well is that you're interfacing with a ton of different kind of other services, other providers that all have their own downtimes and uptimes and whatever. And so you're kind of left on the hook if one of them has issues or changes their interface. A lot of the times you'll have to adapt really quickly. One thing we've noticed that we've been lucky with is actually a funny concept where, for example, Amazon, they make small changes all the time. And so first of all, we try to build interfaces that are robust enough to withstand changes in their spec because they do those unexpectedly. And so we've gotten used to the changes to anticipate. Another interesting thing is that they'll oftentimes, before rolling it out to on a major scale, they'll often do A/B tests, and those are good for us because we'll see like this small error rate kind of crop up, and we'll quickly notice it, investigate it before it affects the vast majority of our users, and say, oh, this is like a new layout, a new page, a new whatever, and then we're able to handle that really smoothly because we kind of know about it before most people do, if that makes sense. But that is the difficulty is providing guarantees around uptime when you can't guarantee that the services that you're dependent on have uptime. And so a lot of the time we just try to do the best we can to show the users that, this isn't our fault, this is their fault. But most of the time it works out okay.
Got it. Sanketh, I think you have something similar with, how do you deal with cars on a 3G connection? It goes through a tunnel, you lose signal. What happens then?
Yeah, so I think there's no silver bullet or easy answer to this. Like Max is saying, you will get blamed even if it isn't really your fault, and you'll take the blame for that. But yeah, like what you're saying, if a car goes through a tunnel or something like that, or it's out of connectivity, this is where I think caching really comes into play, especially for us, because the type of APIs that we're dealing with, it's not the same way as if I owned a server and I could scale out my server as infinitely as I needed to, and then I'm fully responsible for my own uptime. But when a car is naturally moving through areas of unconnectivity, it's planned downtime. I mean, not planned, but it's expected downtime that's going to come in. So it kind of just has to be baked into our system. So basically setting up a caching system that can smartly recognize and save data when the car is available and make it actually exposed to developers. So developers should actually be able to request for, I want this data with the max alive or max age of this much, and then actually be able to get data that is potentially slightly old, that was 5 minutes old before the car went through the tunnel, and that may be okay for the developer. Or be able to tell the developer, nope, we can't actually get that data at this exact moment right now. But basically make it flexible so the developer doesn't really need to think about it, but if they want to, they can provide parameters to actually understand what's going on under the hood there.
One more thing that I thought of is you touched on this, the transparency for the developers or for the kind of people who are interfacing with the API. So obviously it's very nice when they're getting generic errors, they're not going to know what's going on. So like in our case, we do our best to provide either like screenshots or error messages from the sources where we're getting the errors from, so that when they are looking at these errors, introspecting, they can say, oh yeah, this is coming from here, as opposed to just generically failing.
Got it. Tess, anything to add on there?
Not really. Not really.
Cool. So Max briefly mentioned, the idea of A/B testing, and so I think one of the interesting things about Chain is you have this problem where your software is on premise, right? It's deployed to a bunch of servers, and it's sort of like out of your hands. That's sort of this interesting real-world situation where you don't have control over all of the code. How do you do things like A/B testing and rolling out updates in that environment?
Yeah, so updating is really a little bit of a gnarly problem. In some ways, we kind of have the opposite of the problem Max described, where instead of having people spring updates on us that we don't expect, it's like people won't update when we want them to. And so, so when you're building a distributed system where every node in the network might be running a different version of the code, that can make it really kind of tricky to introduce new features, particularly if you're trying to change the format of a transaction, and then you want this new transaction format to get propagated maybe across through nodes that don't recognize that format. That's a really common problem both for us and also for really any blockchain network. Bitcoin sees this all the time. So the basic solution there, in addition to just really meticulous versioning of everything, prior to working at Chain, I had never versioned anything so much in my life. Just the sheer number of versions on every piece of the system was sort of mind-boggling to me. But the other thing is just making sure that that every node in the system knows to just pass. If it sees a transaction that it doesn't understand the format, it doesn't reject it. it just like passes it along to the next node. Like, maybe this guy will know what to do with this, which was like a very different sort of way of thinking about systems for me than anything else I'd done before.
Got it. One extension of that is, so it could be that a client is trying to talk to the API and it's accidentally using a newer format or something that doesn't match with that version. How do you know? It could be someone malicious who's trying to send bad data and sort of reverse engineer the API, or get it to expose some data that you don't want out there.
Yeah, I mean, the one thing that is really different between the systems that I work on and something like Bitcoin itself is, and I didn't touch on this, but one of the keywords I mentioned when I sort of threw out that word soup about what we do is permissioned. So we don't generally run open networks. We have one open network, but it's not, there's nothing sensitive on it at all. So which makes sense for enterprises, right? Like an enterprise usually doesn't want like anyone to be able to waltz in and like go through all their stuff. So that's sort of like the simplest way that we deal with it, which is, I guess, a very API level way of handling the problem.
Got it. So it's kind of built to be locked down.
Exactly.
How about you two? Any other thoughts on sort of how you deal with malicious attackers and sort of cutting them off at the API level?
I guess at the API level itself, do the similar thing of permissioning. Every endpoint that we have is guarded behind a different permission that requires user consent before actually allowing them through. So we have at that level of permissioning built into the API. And then on top of that, things that we have been, I think, experimenting with and trying out with some new clients is things like two-way SSL. So instead of doing just HTTPS in one direction, we can actually identify our clients as well through bidirectional SSL certificates. So trying these newer types, or maybe not newer, but more advanced types of protections on your API endpoints if something is particularly sensitive.
Yeah, I think for us, we don't do anything particularly special. We use basic auth for most things. I think we have two kind of cases. One is where we built applications on top of our API that interface with the API, so the security's handled mostly there in like more traditional web app ways. And then for our API directly, we have kind of fewer larger customers, so we kind of know them very well. We can track exactly what they're doing. It's more about security that way.
Got it. Could you touch on that a little bit more? I think one of the interesting things about Zinc is you have an API, but you also have built certain apps to kind of make it, more consumer friendly or sort of fulfill a certain use case. How do you decide that this should be an API level, a platform level feature versus building something on top of it and distributing that?
Yeah, so it was a very kind of iterative process. I'll back up a little bit. The API kind of, in its original form, came out when my co-founder Doug used to do dropship arbitrage in high school, dropshipping from Amazon to eBay and kind of making some passive income that way. That was where we got the core tech, and then we were like, hey, this is so cool, we should sell this, like later senior year of college, much further down the line. And we tried to sell it in a variety of ways, and actually it took 7 to 10 months of kind of pivots. But we finally, first of all, we kind of went back to that original arbitrage case for a lot of it. We realized the large part of the reason we couldn't sell it was because we were trying to sell this technical product to a bunch of like eBay and Shopify and Amazon sellers. And they're oftentimes small shops that don't have developers, don't have the time and effort. So we realized that in a lot of cases, the API is kind of this 80% case where it'll have most of the functionality that people want, but not presented in the same way, and sometimes in the right way for them to be able to use it. And so sometimes you need this thin layer to allow, for example, non-technical people to access it. And it's obviously a trade-off between customizability and scalability, but for us, we found a few niches like arbitrage, for example, where we said, hey, let's just build a SaaS product on top of our API. It's not that hard. Like the core functionality is really still contained in the API, but it'll make it accessible to like a wider swath of customers.
Got it. Tess, is there something similar with these financial institutions where maybe they don't have a huge developer team and you've got to create the app for them, basically build on top of the API?
Yeah, we definitely have done a little bit of like prototyping and proof of concept work for our partners, but again, that's really about like illustrating I mean, it's, I guess, not that dissimilar. It sort of is about, at the end of the day, it's not really what we're all about. It's more about illustrating what our product can actually do.
I think that's it. Yeah, we're really similar in a lot of ways like that. We've done proof of concept and product work. I think for when you have a new API with something like cars, one of the things is to demonstrate it. You really have to create some proof of concepts to actually show what it can do and make it understandable to non-technical people as well. I think when we first started, sitting around with terminal screen curling things didn't really explain to non-technical people what we were doing until we actually built some demonstrations. So, for example, with I'd say last year at the LA Auto Show, we announced with Hyundai that for their new vehicles, they are using Smartcar's APIs to build integrations like an Amazon Alexa. So you can ask Alexa, where's my car? Alexa, heat up my car before you head out in the morning. Alexa, how much fuel do I have left, to know whether or not you have to stop by the gas station before you, that day. So we've had to build certain integrations and stuff like that to basically show out what the platform can do.
Got it. And how do driverless cars play into that? Will it eventually be, hey Alexa, I need a car, and one just rolls up and I hop in there?
I think what you touched on is, it's really, I think the vision, what we see for Smartcar. I think the future that we see is we want to be the orchestration layer for cars. And when we look at autonomous cars, we think that's one of the major trends happening in the transportation space, but it's not everything. We see these 4 major trends we talk about: connected cars, autonomous cars, shared cars, and electric cars. So we think the future of transportation is going to be a connected, shared, electric, autonomous car. And when you're at that stage, you need an API, you need some kind of platform to administrate and orchestrate these vehicles, tell the car where to go. You have to tell the car who it's authorized for to unlock for, and what destinations it's allowed to get to. The owner of that vehicle, the operator of that vehicle, needs to understand the telemetry of how fast the car has gone, where all has it gone, how much fuel's left, or if it's an electric car now, how much battery is remaining, and where are the closest EV charging stations it can go to get charged up for. And that's really where we see the future going to.
Got it. One idea is around whenever you're dealing with something in the real world, you've got to think about rate limiting. Right? The idea that if I issue a command to a car and it accidentally gets retried 1,000 times, that could do something pretty bad.
Yep.
Is that something that's built into the API?
Yeah, it is definitely something that's built into our API, and there's kind of like actually 2 the types of rate limiting we think about. One is inbound into us, so between us and developers, we have to make sure we rate limit on an app basis, that one single app cannot go crazy and honk a car infinitely, or use up all of its limits. And that's very similar to, I think, traditional rate limiting. Then the other side of it is kind of the upstream or downstream, however you want to look at it, rate limiting from us to the vehicles. So we need to protect the cars. So there may be 10 different apps requesting access, requesting data from a car, but if they're all hitting up the exact same car, we have to make sure we protect that one car from getting hit too much. So we have to throttle on the outbound as well.
Got it. Anything else to add there?
With us, it's nice because orders take actually like physically. Well, first of all, you can always cancel like an order on Amazon or on Walmart or something. So it's not the worst thing in the world. And then also the orders there's like a physical amount of time that they take to place. So it kind of we don't do too much in the way of rate limiting just because we haven't had issues with that.
Yeah, for us, when it comes to like protecting retry requests, we just have like a request token for any request that needs to have item potency. So we just like always check against that. It's pretty simple.
Great. Well, I think we can wrap up there. Anything else you guys want to add?
Thanks, Gordon.
Thank
you.
Thank you.
And I'd love it if you check out Git Put Post. It's at gitputpost.co. And now we'll break for lunch. Thank you so much.